Hello and welcome to my YouTube channel. My name is Siobhan Richards. So the last video, the last hands-on one, we looked at primitive types. These are the basic fundamental types, right? These are the building blocks for your programming, right? We looked at declaring and initializing these primitive types. Now we have this this other category called the reference types. Okay, so these just remember the primitive types. We can't really change any properties on those, right? So these are just static in memory. Okay, these reference types, on the other hand, we could change these reference types. We could change attributes or action on these reference types. And these reference types are typically used to create objects, which give rise to the object-oriented programming paradigm. Okay, so in Java, there are but a few reference types, right? We have the class type, interface type, array type, enums. Okay, so these are the four reference types in Java. Okay, so let's look at just basic creating and initializing these reference types. So just to note, like right here, it says main.java. Typically in your Java file, you need a public, public class. This is the one that's going to be returned from the from your Java file, and we'll change that to the same name as the main. Okay. All right. So we have this public class here, and we also need this other class here. So we'll start with this reference type, creating a class. Okay. So this class here is to create a template for creating objects later on. Okay. So to create a class, I mean, it's shown here, right? It's all shown right here, but we'll create our own, right? So I'm just saying, like, Java is object oriented from the get-go, right? So it actually shows you how to create a class, or okay, so class, you do the class name my first, and you want to make these capital letter, right? So my first class, let's make it like that. And we need this curly operator on these reference types, so we could say, let's make a comment here. So in Java, this curly operator creates reference types. Okay, so it has many different functions. So okay, so now that we have the class, we need to add the attributes and the action. Okay, so let's make this a class that represents the classification of persons, right? So persons typically have a name, and we could have phone number, but phone number would be a string. So let's make it an integer user ID. So let's do string for the name. Okay, let me remove that name here. So it's the string primitive type name, and we could set it equal to Elmo. Okay, that's the name of the person. The other thing we might need is user ID. So int user ID. Okay, and we set that to an integer. Okay, 213. Remember that integer range is very large, right? So we could have a whole different level of counting numbers here. Another thing that the class could have is methods. We could have the constructor method as well as other methods that you may make. In this case, since we're just learning programming, we'll just stick to this class that's a static class in a sense, like, meaning it represents a static object. So let's say this object doesn't have any actions. Okay, so only attributes, right? Only characteristics. Okay, so this person doesn't do anything. You just have a name and a user ID. Okay, so how do we access these values or update these values in our class? Well, this is our main method here, right? So this is the starting point of your program. So let's look at creating this object, right? So let's look at creating one object of this class. So again, this class are like data types, your own data types. So my first class, let's call this person 1, first person 1. Okay, and you need this new keyword. Okay, and you need the constructor. in our case, we didn't have a constructor, so we'll call this class here and make it empty. Okay, semicolon. Okay, let me make this a little more so you could see better here. Maybe a little more. Okay, so that's that's how you create your first object of that class, right? So your first object of that class. Let's see what this says here. So it executes, everything is fine. Let's try accessing these variables, and you might see error here, but let's try. Okay, so let's try to access these variables here. So the first variable is a string, so we need a string to capture that variable. So string person1, and we could call this person1 name. Okay, so let's put person1 name here. Okay, so person1 name should be person1 dot name. Okay, so that's how you get the name. Let's say we need person1 user ID, so it's an int person1 user ID equal person1 dot user ID. Okay, and just to note here, this line here matches this name here, right? So it has to match the template that you have, okay, which is the class template that you have. All right, so the next step is to print. So let's do a system.out print line. Okay, and then person1 name, that variable there, plus need some space here. Okay. Okay, so something's up here. Need some space here, and print the ID. Okay, so person1 user ID. Okay, so that's how we got. That's how we're gonna print out to the output here. Person1 name and ID. Okay, so it prints person1 name and ID. So this one here, so we access the name and ID for person1. Okay, but what if we want to make this class to be nested, right? So let's say we want to move this class here into the class main. So if we do that, we could copy here and let's put it here inside the main class, because maybe we need another class in main. Okay, and let's see here if it still works. Okay, so just remember that scoping that we were talking about. Okay, error. Okay, so if we need to use this class here in main, we can't name it class. We have to add that static variable there to share it internally with these values here. Okay, now we could access these values. Okay, so that's a static keyword there. Okay, so what's the next reference type we have? Okay, we have interface type. So this is like a list of methods that you may use. Let's say you're planning your object, so you have these methods that you think are probably necessary, right? And you could use these methods and use this interface, and then it could be shared among different classes that may need that method. Okay, so it's a way of, you know, shrinking code base, and you could overwrite the method, so you could have different different functionalities tied to the same name, right? So that's polymorphism, right? Override. Okay, so let's create our first interface. So let's say interface here. Let's do interface here, and since it's inside this main class here, we're gonna make it a static interface. Okay, and see. So static interface, my first interface. And again, this interface here is just a list of like methods you may need. Okay, so this method here, let's call this a printing method. So void or alert. Okay, alert. Let's call that a void alert. So it's a void method. that just alerts people. Okay, and we'll see how we work with this one. Okay, so let's make that there. Okay, so let's run. Okay, no problem, no issues here. So we have our interface here. Let me delete these here. These couple lines here. All right, so we have this alert method here. What if what if we want to use this alert method inside or my first class here? Let's first add another class here. Okay, so let's do a static class. Let's call this my second class. All right, and let's make this a new person here. Okay, let's make this a new person here. Okay, let's call this name 2 and user 2 ID. Okay, and let's change this to Bert, and let's make this user ID 100. Right, so we have two classes here. We have our interface and we have two classes, and the reason why I made a second one is to show you the benefit of the interface. So let's run to make sure I make my classes right. Okay, let's see how we use the interface. So interface is kind of like you're going to use some inheritance here, right? So to do inheritance, which we'll cover later when we look at object-oriented programming, we need that implement keyword. So implements. Okay, and it needs to implement the interface name. So my first interface. Okay, let me shrink this some more here so that you see that here, and then let's do implements. My first interface. Okay, let's run. Okay, static class here does not overwrite. Okay, so it's saying it implements, so we need to do the overwrite here. So you need at override. Okay, so at override, and then we need to override that method. Okay, so just make it a public method. I know it's getting a bit hectic here, so just remember, we're just adding action. We're adding one single action to my first class 1, and then one single action to my first class 2. So we could say public void alert. So public here makes alert public, and inside this action we'll do a system.out system.out.println, and this alert will be let's say alert from message from class, let's say my first class 1. Okay, so my first. Okay, all right, so we have these alert methods here. So over in my second class, okay, we could have this alert. We could just keep the same override here and that alert message there. Okay, I would print bad there, so let's make sure it doesn't matter, but just to keep consistency here, we need those semicolon here. Okay, and let's now run. So what we did was we update first class with this method here that is coming from this interface here. Why are we doing that? Maybe we need these same methods, the same method name, right? So we don't want to keep creating different method names and it's doing the same function. So we could have this interface of all the necessary methods we need and then share them among the classes. It's better for organization. It's better clean code, which we cover. Okay. and it's more productive there. Okay, so at override. Did I spell that wrong? Okay. Oh, 2 R's. Okay, so overrides. Okay. Good. Okay, system.out. Okay, misspelling errors here, so I'm doing a lot of syntax errors here. Okay. Okay, so now it works. All right, so now let's say we want to alert. So remember, we have this my first class person1. So let's do my first class, my second class. Let's call this my second class. All right, so with another class. So this is person1 from my second class. All right, and we call this new my second class. Okay, so Java is very nice, right? It's like object oriented from the start. Okay, so you could do all these. It's already tailored for you to write object oriented code. Okay, so my first class here, right, implements this interface. My second class here implements this interface. My first class has this attribute name, and it's initialized to Elmo, and it has the second attribute username initialized to 213. Second class has this attribute name2 initialized to Bert, right, and user2 ID initialized to 100. I could have kept the same, right, but it's just to show you the change here. Okay, so if I need person2 name, right, I'll do string, because I'm expecting a string return, right? So string person2. Well, person1, right? So this one was person1 for my second class, my first class, and this one is person1 for my second class. I mean, I could have named it person2, but it's person1 of a different class. So person1 name, let's call this person1 2 name. Okay, let's say, right? So now we'll do person1. Let's change the name. Let's make this person2, just to not get confused here. Okay. Okay, person2. Person2 name equals person2 of the other class. Right. Dot name2. Okay. And then now we could do person2 ID. So int person2 user ID equals person2 dot user2 ID. So user2 ID. Okay. Let's see if we make any errors there. Okay. No error. All right, so now we could print. Let's copy these print statements here. Save some time there. Okay. So now instead of person1 name, we have person2 name. And instead of person1 user ID, we have person2 user ID. Okay. So that's, let me kind of make some space here that you could see what's going on in this main method here. Okay. Okay, so this is our main method. Okay, so that's what we're looking at. All right, so now we should print Bert 100. So that's the second class. Okay, what if we need to do alert? Okay, let's see here. So we do system, and you'll see what's going on, what the interface did. System.out.print line, and we'll do person1, right? Person1 dot alert. So we call the alert function from person1. Okay, just remember this dot notation is what we use to call things that are tied to the variable, to the class, and it's usually attributes or action. Okay. Okay, so we have alert. So if we do person1 dot alert here, we'll see what it alerts. Okay. Void type not alert here. System dot out person1 dot alert. Okay. What's going on here? Oh, my fault here. The thing is, person1 dot alert person1 dot alert is already printing something. So all we need to do is just call it person1 dot alert. So my bad there. Okay. So it's already printing. So we don't need a print statement to print the function. Okay. So here it says alert from my first class 1. So if we need to alert from my class 2, we do person2 dot alert, and you'll see the difference. Okay. Here it is. Wait, well, I needed to update this. Okay, so this one should have name alert from my second class. Okay, second class. So my bad there again. Okay, so you need my second class here, and because we're basically overriding this alert here that is tied to this interface. Okay, so let's do that. So that's here. All right, second class. Okay, so that's this one. All right. Well, this didn't need one here. My bad again. Okay, so we've looked at class. All right, we looked at interface. All right. So the next one here is enums. So enums are usually these set of constants, right? So you have this constant that you could access in your enum, right? So it's basically the same way, right? Same way. For arrays, we'll look at arrays later when we cover control structures, right? The loops. But arrays, let's look at declaring, initializing arrays. Let's do that. Okay, let's create an array here. Alright, so let's say I need an array. First, I need a data type for the array. So int, let's say it's an int type. You need the square braces, my first array. And we could initialize these to some values. Okay, so let's say we have 10, 20, 30. Okay. So now we have an array of 30 values. Okay. To access this value, just forget about down here for now, right? Except for the main method, which we'll go into. So we have this array. Let me put it down here. Okay, let's put it down there. But we'll look at array again in control structures. Okay, let's comment out this guy here. So let's look at accessing this array. So we have an integer array. These have 3 numbers, and the arrays are 0 index. So if we need to access this array here, let's say first value, let's say int first value. We'll call this my first array of 0. Okay. Let's do second value. My first array of 1. And then third value, common letter, okay, third value, but I wanted you to see the array. Okay, so third value, my first array, the name of the array, of 2. Okay, so that's third value there. Okay, if we run this, shouldn't be no problem. Well, my first array. Oh, okay, so here we need that static. Okay, remember, we always need that static to share. My first array. Okay. Spelling error here. So when it says cannot find a symbol, it's usually a spelling error, right? Or something. Okay. All right. So we've declared initialize all those arrays. So let's do system.out.print print line here, and let's do first value plus space here. We could do a /n here. Next is /n. And then second value plus /n here. And then third value. Okay. So that's declaring initialize. So we declare, this is declaring and initializing an array. Okay. This is accessing an array. This is printing printing an array, right? So we access and we could print these values. Okay, 10, 20, 30. That's what's in there. What if we need to do an update? Okay. So we could update by using the array name. So my first array. And let's change this value. Let's change the third value to 60. Okay. And then now let's do, so we just changed the third value to 60. Let's now re-access that value, right? So we've changed the third value to 60. Now we are going to access again, right? So third value, because we're re-accessing. We can keep the same variable. We don't have to change it. And then do my first array of 2. Okay. Now we'll do a system.out.print line of third value. So we basically overwrite the third value that we had before. Okay. We just kept the same variable here, and we've changed, because it's a reference type, we change the structure. We change, not the structure, but the location. We change the value inside that location. And then now we access that value again. So we overridden this value we had before to this new value here, which is, it should return the 60. Okay. What's going on here? Okay, I forgot the T. Spelling error. All right, so now it changed to 60. Okay, so just notice it's the same position there. Okay. All right, so that's array, declaring and initializing array, and we'll we'll revisit arrays later in control structure. The last type we have is the enum type. So you need that enum keyword. Let's say it's an enum of, in this one we had prices. We could have an enum of category, right? Let's say it's a category of books or something, category. Let's call this book category. All right, so book. Book category. Yeah, variable names are the hard part. No, I'm just playing that. All right, so book category. So what can we have as a book category? Usually we want to keep these all caps, right? Because they're constants. So what can we have as a book category? We could have fiction and non-fiction. So let's do non-fiction here, and let's do fiction. So we have two types of books here. Okay, let's run that to make sure that we declare these properly here. So we have our comma here. What's going on here? Okay, we probably need a static here. So let's know static. See what goes on here. Okay, we can't have, okay, yeah. So we can't have that hyphen there. All right. So yeah, because these, well, I'm not, yeah, usually in variable names, right? Because these are kind of like variables in the enums. They don't want you to have that minus there. No? Not sure, but it doesn't like it. Okay. All right. So these are enums, right? So no sort of symbol, no hyphen inside the name. So we have nonfiction and fiction book here. So let's access fiction or nonfiction, right? So it's really no different here, right? So you declare enum, right, by the enum name. So book category, right, and we have our name. So this is our, remember these reference types are like you're creating your own type. So we have this book category type, right, and we'll name it book. Let's name this book category. Book category 1, right? And then we'll then call the book category object. So can we use a class to represent the enum? Yes, right? So if you know classes, you'll know what an enum, right, is, okay? It's just another way. It's just a specified, it's like a subset, right? It's a specified class in a sense. So classes is the overall programming on a whole, right? All right, so okay, so book category dot nonfiction. Okay. All right, so let's run that, see if it works. Okay, all good. Let's do a system. Okay, let's do it here. So system dot out print line book category 1. Let's make this a capital C here. That's how I like my variable names. Okay. All right. So let's see if it prints nonfiction here. What's going on here? System.out print ln. Okay. Be making spelling errors. Okay, nonfiction. There it is. It returns this nonfiction from the enum type. So we've covered all the reference types in Java. Okay, we've covered declaring, initializing, right? We looked at declaring, initializing classes, declaring, initializing interfaces, arrays, right? We didn't use the for loop because or while loop, but we'll revisit that in control structures. We also look at declaring, initializing enums, okay, so which are constants, right? All right, so these data types are typically used for, again, large scale, like not large scale, but objects, right? So you have objects that has some attribute and actions. So we usually use these reference types for those, especially classes, right? And arrays are a collection, right? So it's the list version of Python, right? So this is arrays is the list in Python, okay? And that covers our reference types. So again, these data types will cement your foundation in the language for you to build more complex data structures, right? So these are the foundation to build these nested data structures, whatever you need however you need to structure your data, right? These are the cement, the building block, the iron, right? Whatever you need to create your house of basically your tools you need to create your data structures necessary later on in data structures and algorithms. Okay. All right. So the next time we'll pick up on typecasting, right? and then we'll move to operators. Okay, so we look at declaring, initializing, then we'll look at how do we typecast these data types. Okay, how do we move from one data type to the other data type in the compiler, in the programming language, and how do we move from, and how do we mix, right? So how do we add operations to these different data types, right? What if we need to do add addition, subtraction? We already see one operator here. This equal sign is not really equal. It's saying you're assigning this data type this value. So it's an assignment operator, and we'll cover that some more. Okay. Thank you again for listening. Hope I'm making some impact here. Thank you.